Let's talk about electric circuits connected in series. The questions we're going to deal with is, first of all, what is a series circuit? And we're going to look at how is voltage and current distributed in a series circuit. So here I have a sketch of a light bulb in series with a battery. Now there is only one way to connect a single light bulb with a battery. We have a battery, wire, light bulb, wire, battery. There's no other way of making that connection. But what happens if we wanted to connect 2 or 3 light bulbs together? Well, one way of connecting 3 bulbs to a battery is to connect them end to end, still maintaining a loop for the circuit. So we still have one continuous loop, and what we're doing is connecting battery, wire, light bulb, wire, light bulb, wire, light bulb, wire, battery. Again, it's one continuous loop, and we say that these are connected end to end. It's as if these light bulbs are holding hands in a single loop. So connecting resistors, in our case a light bulb will serve as the resistor, end to end is called a series circuit. So how is voltage distributed in a series circuit? What I have is 3 examples for us to consider. In all cases, we're going to use a 6-volt battery. When we connect one light bulb to a 6-volt battery, you see that we have that one loop. The 6 volts goes into the light bulb. 6 volts comes out of the battery. 6 volts goes into the light bulb, giving it a particular brightness. Now, if we take 2 identical light bulbs, they could be different, but for now, let's talk about identical light bulbs only. So if we take 2 identical light bulbs and connect them in series to the 6 volt, what will happen is the 6 volt will be distributed evenly into the 2 identical light bulbs, making each light bulb half as bright. Remember, earlier we studied that there's a relationship between brightness and the voltage that goes into the light bulb. So the 6 volt is distributed, 3 volts go to the first, and 3 volts go into the second. If you think about the model that we used earlier with the paper clips, where the battery, say, has 6 paper clips. Well, as the charge carriers move through the circuit, they deposit 3 of those paper clips in the first light bulb, leaving 3 paper clips for the second light bulb. So it's an even distribution. Now, if we have 3 light bulbs, then that 6 volts is going to be distributed through the 3 light bulbs. So consequently, we will have 2 volts here, 2 volts the second, and 2 volts on the third. So the brightness of the light bulb will be 1/3. So again, 6 volts distributed evenly into 3 identical light bulbs will make it 1/3, as each light bulb 1/3 as bright. Now we can summarize these ideas in a formula. We can say that the total voltage, that would be the voltage in the battery. We can also say that's the voltage in the entire loop. 2 ways of looking at that. So VT, voltage of the battery, in series, is going to be equal to the voltage in the first bulb plus the voltage in the second bulb, and so on, depending on how many bulbs that we have. Now, what about current? How is current distributed in a series circuit? Well, what I did is I redrew the diagram with the 3 light bulbs, and I just want to emphasize the fact that current leaves the battery, goes into the first bulb, current then goes into the second bulb, and current then goes into the third bulb and back into the battery. So again, if you think of our electron shuffle model, the electrons shuffle one after the other. and they don't pass one another. So if they're shuffling together, they must be shuffling at the same rate, which means that the current in that loop has to be identical the entire way. So whatever the current is at this point, it's going to be identical to the current at that point, which means that the current through that bulb is equal to the current through the second bulb, and is equal to the current in the third bulb, and so on, as long as the bulbs are connected in series. So whatever current goes through the first light bulb goes through the second, and then it goes through the third, and then it returns to the battery. So whatever current comes out of the battery, that's going to be equal to the current through each light bulb. So that gives us a simple formula that says that the current, the total current in a series circuit, is equal to the current in each component. Each resistor will end up having the same current. I means current.